All right, hello world. My name is Albert. I'm a developer advocate at Alchemy, and I'm so excited to be here with you today in this video to walk you through an example of a hello world smart contract where you can, by the end of this video, you're going to be able to write your own Solidity code, deploy your code to the testnet, one of the testnets in the Ethereum ecosystem, and also be able to interact with that smart contract and just kind of get a sense of how everything starts to tie together. Because I know a lot of people out there are starting to explore Web3 and blockchain, and this is a great way for you to get started, kind of seeing how everything fits together. So if you're ready, let us get started. When I was learning, one of the biggest pain points is that I had a hard time understanding like what all of these different tools were and how they fit into what I was working on with the smart contract code. So if you can excuse my bad drawing skills for a second, you can see up here, this is basically my rendition of the Ethereum blockchain. You can see in each block, there's a list of transactions that gets recorded in the history of the blockchain. And you get to store smart contracts on the blockchain as well. So this is what we're going to be working on today. We're going to be building one of these smart contracts, deploying it to a test network, so not the real Ethereum, but it's kind of like similar concepts. And we're also going to be sending transactions to that smart contract to interact with it, and and you'll see how everything works. So this is where the confusing part comes in, because it's like, okay, well, how do I get to that point where I deploy that smart contract? So at a very high level, there's a couple of tools that you're going to be seeing throughout the rest of this video, and you can refer back to this portion to kind of review it. But we're going to be using Alchemy, we're going to be using Metamask, which is this cute fox, and we're going to be using Hardhat. So Alchemy is this kind of one-stop shop. It's a platform to make it really easy for you as the developer to get your smart contract from your local development into the blockchain. And this type of a service is called a node provider. There are a lot of node providers out there. Alchemy does way more than just node providing. We actually have some really awesome APIs that I'll also show you in this video. Metamask is what people will use. It's very popular. It's a wallet. It's a virtual wallet that people use to interact with the Ethereum blockchain. I can actually show you here. This is my wallet on the Ethereum mainnet. It's one of my wallets. It's a test account with no money in it. But it's really nice because there's this extension, it just pops out. And when I go to websites where I want to buy NFTs or do DeFi or anything like that, this wallet is ready to go. So those are two different ways. Alchemy, an Alchemy app, and the MetaMask virtual wallet, those are two different ways to kind of enter the Ethereum blockchain. And so on this side of things, while we're developing our smart contract code, we're going to be using Hardhat to test, to run a deploy script that actually talks to Alchemy and to do a bunch of other local development things. So that's what the Hardhat tool is. And over here is just me as a person who's interacting with MetaMask. These are kind of like two separate paths that you can kind of take. So yeah. If this doesn't make sense, then let me know. I'll think of a better way to explain all of this. But for now, I just want to kind of give an overview diagram for people who haven't seen it before. Okay, let's move on. All right, so a quick overview of the things that we are going to be doing in this video. The first thing is we're going to get you set up with some accounts. So this is your MetaMask virtual wallet account, your Alchemy node provider account, a lot of different things that will really help you get going once you set it up one time, and then you'll be able to use it for all your future development. So account setup is pretty important. That's the first thing. And then the next thing will be to deploy a smart contract. So we're going to write some Solidity code, and I'll walk you through the steps there on what each line means and what's going on there and why we need to write a smart contract. But you can basically think of a smart contract as a program that lives on the Ethereum blockchain. So that's step number 2. We're going to write that code and deploy it into a testnet. And then the third thing that we're going to do is to interact with the contract. And this is pretty exciting because after we deploy it, the whole point of deploying it is so that we can do certain things with that contract. So we're going to be setting a hello world string on that contract state. When we deploy it, it'll have the string initialized. And then when we interact with it, we'll be able to update that value, and then we'll be able to query for the new value. So you can kind of see how the data flows in this whole system. And then finally, we're going to verify the contract on Etherscan, which is a very popular blockchain explorer. And the benefit of verifying it is that once you verify it, anyone across the entire internet can interact with your contract without having to ask you about how the code works and without you having to build a front-end web page, although that is something we will want to do in a future video. So by the end of this video, you're going to be able to do all these 4 things, and it's going to be awesome. Cool. So the first thing that we want to do actually is create a MetaMask wallet. You saw that I already have a MetaMask wallet there, but for you, if you don't have one, you can go to metamask.io/download.html, and it should take you to this page that says install MetaMask for your browser. And there's this big blue button right here that just automatically detects your browser. Mine is Brave, but if you have Chrome, Firefox, Brave, or Edge, those will all work. So you just click on that button, and then it should take you to this extension store. I already have it, so right now it says remove from Brave, but for you, you just install it, go through the steps. There's a nice tutorial that they put you through, and then you'll be set up. So you should be able to see your wallet via this extension. If you don't have it here, you can actually just open up the extensions, hit this pin button, and then it'll be pinned to your browser, just for convenience. So for you, you probably see this like account 1, I think is the default naming. And one thing to call out is if you want to create multiple accounts for testing different apps or whatever, you can always hit create account, and then you can make a new account here. And this cool thing about the MetaMask virtual wallet is that it maintains all of these different wallets, these different addresses within the MetaMask wallet. So yeah, I'm just gonna pick my test account wallet for now. That's the one I'm gonna use to be building stuff. Now, the next thing we wanna do now that we have a MetaMask wallet installed in our browser is we want to get some fake ether that we're gonna be able to test with. So one thing to say about MetaMask is that this is kind of your virtual identity in the blockchain world. This address right here, if you go to Etherscan, which is a blockchain explorer, and I paste in my address, you can actually see this is the history of all of the stuff that I've done on the blockchain, which is nothing actually, because I haven't done anything on the mainnet blockchain with this address. But once you start doing that, then you'll be able to see everything. And so this is kind of like your identity. It's who you are, it's where you hold all of your assets and all of that stuff. So it's pretty important. Okay, so anyways, getting some ether. We're gonna go over to the Robston Faucet, and this faucet is pretty good for the Ropsten network. So if we go to this website page, you'll see that this says Robston Ethereum Faucet. And what Ropsten is it's one of the test environments for Ethereum. It's really good for developers who are trying to test out their smart contracts. If you click on this drop down right here on MetaMask, you'll be able to see all the different test networks. So we got Ropsten, Coven, Rinkeby, Goerli, and then there's some custom ones that I had set up. But we're gonna load the Ropsten test network. And you can see here, I've already done this step with getting some fake ether, so I already have some in my account. But you're gonna do the same. So all you have to do to get your fake ether is click on this copy to clipboard and enter it into this bar right here. And then you're gonna have to do some CAPTCHA stuff just to prove that you're a human and not a bot trying to drain all of their ether. So you're gonna have to click through some of these. And once you've proved that you're human, then you should see this message at the bottom here that says, congratulations, your address has been added to the queue. If you found our service useful, blah, 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 blah. So adding it to the queue just means they're going to airdrop it soon. So if I check my wallet here, in a moment, it could go anywhere between 10, 15 seconds, all the way up to a couple of minutes. I think in the worst case, it's been like 10 or 20 minutes. Sometimes faucets can be pretty buggy. So if you have an issue with this, go to the Discord link that I dropped in this description for the video. And we have a really supportive community there. So you can just ask for some Ropsten testnet ether, or you can tag me, Albert, at Albert. I'll put my Discord thing somewhere on the screen here. And I'll be able to get you some. So anyways, if we check the Etherscan address again, but we go to Ropsten.etherscan, then we can see whether or not that transaction came through. So you can see here, it's still pending. It started about 17 seconds ago, but it hasn't been included into the blockchain yet. But there's a value of 5 ether that is coming in. So let me make that bigger here. 17 seconds ago, 5 ether. Okay, so while we're waiting for that to happen, it's pretty much like It should go through, no problem. We're gonna start creating our Alchemy app. So this is another setup step before we get to the actual coding of our smart contract. So let's go to alchemy.com. I'll put a link in the description below for this as well. But this is the official website, blockchain development made easy. You're gonna see, I think, a sign in button here. So once you click sign up button, once you click the sign up button, go through the flow, set up your account. And once you've set it up, it should look something like this after you log in. You're taken to this team dashboard page. Let me make this bigger as well. You can see I already have some apps created, but on the free tier, you can create a decent number of apps for you to start playing around with. What we're gonna wanna do after you're at this step is to create an app. So just click this button. We're gonna call it Hello World. I actually already have one called Hello World, so I'll just call it Hello World again. For the description, this could be like, this is my first decentralized application. And then this environment dropdown really is for bookkeeping for your purposes, because you might have multiple Alchemy applications over time, and you might want to separate them from, separate like the development ones from the staging ones from like, hey, this one is actually serving real customers in production. So for our purposes, let's just target staging, because we actually plan to build on the Ethereum, one of the staging blockchains. So we're gonna pick Robston here, and this is really key. Make sure you pick the same network that we are getting our Ether on and that we're going to be deploying to. This is pretty important. So once we've gotten that, we click Create App, and you'll see it pop up on your table. And then if you click into this app, we have some really cool useful metrics, such as how many requests have been made to your application in the last 24 hours. There's like an actual area where you can kind of essentially look through the stack trace of the requests and see if anything went wrong, or if you're getting rate limited because someone's spamming your application and things like that. But we'll go into this later. So now that we have the app set up, this view key button is where you'll find the API key and the URL. So this first portion, ethropsten.alchemyapi.io/v2, that's kind of like the base URL of how to hit the Ropsten network through Alchemy. And then this part is specific to you. I'm showing you right now because this is a tutorial, but in general, you don't really want to show people this because then they could spam your application with requests. But this is your API key. So this is your API key that maps specifically to the Hello World Again project. Okay. So anyways, you can write that down somewhere or just keep this window open. We're going to come back to it in a bit. And let's just double check that our Ether came in. So let's see. Okay, cool. Yeah, so we have almost 10 Ether now. The transaction finalized 4 minutes ago, and we are all good. We have our Ether. And then something I can show you real quick inside the Alchemy tooling is if you go up here to the Composer tab, this is a really cool UI that gets you some similar information as Etherscan, but it's also more flexible because there are a lot of different things you can look up, not just how much Ether an address has, but also some other things. But for example, if we wanted to look up the balance of my wallet, there's a function called get balance. You can also start typing in here, get balance, and that should pop up. And you'll see here, it's asking for an address input. So again, we can copy my test account address. And we do want to query it, the blockchain at the latest state. So we can send that request. And you'll see here it's 0, but that's actually because the network I set is not Ropsten. So it should be Ropsten. Let's resend that request. And then boom, you'll see a result here. So you might be thinking to yourself, okay, wait, what is this result? What's going on here? Why is what is this preview? This is actually what you would have to do as a developer if you did not have something like Alchemy, or Etherscan, where if you wanted to find information that's key for how you operate, you actually have to construct this JSON RPC request structure. And these are the input arguments for that request. Then you have to use something like curl or postman or however you want to make the request. You have to request it to a node. So you have to then set up a node, and then you get this response. And this response is like, the data you're looking for. So with Alchemy, it like abstracts all of that. You have this nice user interface and you get this response. And then the question is, what is this response? Isn't it supposed to be something like 10 Ether? Like, what is this? This is the hexadecimal value. So if we go to a hex to decimal converter, and type that in, then you'll see that this is the same as the ether value that we have here. So this is 9.9989 ETH, plus some decimals that aren't being shown probably. And this is 9.998 and all the rest of the decimals that aren't shown. But there's no point here because this is actually showing how many way there is. And we'll zoom into there a little bit. It's showing how many way there is, WEI. That's the smallest unit of the ether currency on the Ethereum blockchain. And there are, in one ether, there is 10 to the 18 way. Okay, so just a little bit of a trivia for you to know. That's why this is, it actually has like 18 digits right here following the first one. So anyways, cool thing right there. That's the Alchemy Composer. It helps you compose requests and get responses. And this was also a great sanity check just to make sure that we have Ether in our wallet. So yeah, we finished all of our setup steps. Hooray. And now we can actually get into the coding. So let me zoom in there a little bit. We're going to start a directory called Hello World. So we can do make dir hello world. And this is where all of our contract code, our tests, our deploy script, all that stuff is going to live. And then let's just cd into that directory. So right now it should be empty. Yep. Okay. And then we're going to initialize a node project. So let's just do an npm init -- yes. Oh, and by the way, if you don't want to follow through this video, or if you want to look at the code beforehand too, I'm going to put all of that stuff inside the YouTube description. So there's going to be a GitHub repo. You can see the docs version, the written version of this video tutorial, and any other resources that you might need. So it's all down there. Cool. So npm init yes just helps us start that package.json configuration file for our project, and it just defaults all the answers to yes. So yeah, didn't mean to copy that into the terminal there. But okay, so we've initialized it, and you can see here we do have our package.json, which is great. The next thing is we're going to download Hardhat. And remember I showed you Hardhat, this little icon guy thing. This is a tool that we're going to set up in our project. So we're going to go npm install -- save dev Hardhat, and that'll take a second to install. But the cool thing about Hardhat, let's look up Hardhat real quick. The cool thing about Hardhat is they have really good documentation. Everything just works really easily out of the box, and you'll start to see this as you do more tutorials and learn more in the ecosystem. This is a tool that a lot of developers really like, and it has great plugin support and things like that. So it's awesome. Okay, great. So that is installed, and then now that we've installed Hardhat, we're going to use it to start a Hardhat project as well in this directory. And so you'll see here what I did was, sorry, I should have said it. I ran npx hardhat, or did I do it? Here we go. I ran npx hardhat, and the first time you run that in your project, it's going to ask you, what do you want to do? Do you want to create like a sample project that actually has some boilerplate smart contract code and test code and all this stuff? There's some different options, but what we're going to do is we're going to go through and create an empty Hardhat config, and I'll help you fill it out as we go through this video. So that's been created, and you can see here we have our package.json. We have some other stuff that's been generated after we installed the Hardhat tool, and then we also have our hardhat.config.js, which is great. So you with me so far? Hope so. Cool. So we can open this up in VS Code, which is my code editor of choice. What's going on here? Oh, okay, here we go. All right, so let's open that up. Okay, so you probably just saw me run a really weird command code period in my terminal, and then boom, my text editor just popped up. So I just wanted to add a little bit of context on this. This is actually something you have to set up if you want to use it yourself as well. You can see down here I have my Visual Studio Code, and this is my code editor. In here I have some things set up so that this command can work. And basically, you saw me run the command and it opened the text editor, and that's super convenient because now I'm directly into the project that I want to modify. So the way you would set that up inside your VS Code as well is you hit Command Shift P and pull up the shell command. If it doesn't pop up for you, just type it in, shell. It should be the shell command install code command and path. And once you run that, it will immediately install the configuration for you. And I believe you just have to restart your terminal. So just quit that, open up your terminal again, and then you should be able to run that code command. Clear that. Okay, cool. And then make this a little bit bigger here. Awesome. So you can see here we have our node modules, and there's just a bunch of dependencies that were installed. We have our package JSON that just has the default configurations. The package lock includes, should include some hard hat stuff and all the dependencies. And then here is the empty hard hat config. So far so good. This hard hat config, just to explain what this is this is where all the settings for the blockchain specific stuff that's going to be happening live. So for example, so far we have a default Solidity version. That's the language that we use to build our smart contract of 0.7.3. And you can change that to something else. We're also going to have some configurations here for how do you deploy to the test networks, how do you deploy to the mainnet network, and I'll show you that in a bit. So the next thing we want to do is let's add a contract folder. So you can actually right click new folder, or you can make dir here, contracts, and make dir scripts. Wait, how do I? There we go. Okay, some stale state there. So we're gonna do make dir contracts, make dir scripts, and you can see them popping up over here. They're empty right now. So contracts is where we're gonna be storing all of our Solidity smart contracts, and scripts is where we're gonna put things like the deploy script, and also if we have an interaction script, it's gonna go there as well. And then we're just gonna start writing the contract. So let's create a new file in here, call it hello world. And the file extension is called Sol, because that is the abbreviation for Solidity. Now the first thing that you always wanna have in a smart contract is what version of Solidity do we need to run this smart contract code? And the convention is just to use this word pragma, and then you follow it with Solidity, and then you can set your version. So there are different ways to set the version. For us, we're gonna do greater than or equal to 7.3. And you can learn more at this link. I'll paste it here. It's gonna be in the source code that in the GitHub repo. So if you wanna Google it, you can just Google it. Let's keep the code a little bit clean here. Cool. So we have the version now. And then the next thing we want to do is, oh, there's a warning here. What's this warning? SCBDX license identifier. Okay, so you'll probably see this in all of your files. What this means is just that this file needs to know about what open source license this file has, whether or not it even has one. So you could just do a comment here that says SPDX license identifier. And since I don't care, I like it's fine if it's open source to me, I'm just gonna do MIT, and then that should be fine. That's gonna make the error go away. And then we're gonna start our contract code. So let's write contract, hello world, and then it's gonna look like that. So with a contract, there's really two things that kind of go into the contract. One is the state variables, the kind of like stuff that you want your contract to keep track of, whether that's like your NFTs or some kind of a hello world message or some ERC20 tokens, whatever it is. There's the state, and then there's the functions that allow you to read and write and modify that state. So that's really what we're going to be building. And then there's also a third thing, actually. There's events, where you can call an event when something happens, when a function is called, and then everybody on the blockchain will be able to know, like, okay, this event is happening. So we actually want to set an event here, and we can call it updated messages, string, old string, string, new string. So this is not actually a function, it's just an event. And all this is saying is we're gonna pass in like an old string, we're gonna pass in a new string, and then when this event is broadcast, everybody will be able to see that this updated messages event happened, and here was the old string, and here was the new string. So you'll see later where this event comes in, but for now we're gonna define the state that we want our contract to keep track of. And you'll actually notice along this way, especially if you've had some JavaScript experience previously, Solidity code looks a lot like JavaScript, but it's actually really different under the hood. So that's good and bad. But anyways, this is a string type. It's going to be public, so that means everybody can read from it after you deploy it to the blockchain. And it's just going to be called message. So yeah, this variable is going to be stored permanently on the blockchain, so anybody can access it. And then we're going to go to the constructor method. This is a very special function that lives in the smart contract. It's deployed. It's run only once when the smart contract is deployed. So we're going to go constructor string memory init message. And what we're doing here is we're saying that when this contract is deployed, we require an argument to be passed in as well, called init message. And then what we're going to do with that argument is we're going to set our state variable message equal to init message. So deploy it with like a hello world message, and then the smart contract is going to know that this message is set to hello world. And then finally, we're going to have our function. It's a very simple function, but it's going to be called update. And like what you might guess it would do, it's going to update the state variable in the contract. So let's call it string memory new message. So again, this is taking in one argument called new message. This is a public function. This is what's called a, actually forget what this is called. This is like a keyword in Solidity that basically tells us what the access level of this function is. So you could have a private function, and when it's private, that means no one else besides the logic inside this smart contract can call this function, which would make this very not useful. So we're going to keep it public. And then we're going to open up the logic here, and I'm just going to copy and paste this in. So what we're going to do is we have this string memory. There we go. We have this old message. We're just going to temporarily like keep track of that. We're going to set our state variable message to the new message that we passed in. And then the reason we kept this old message on the side is so that we can emit this event that we defined earlier with what the old message was and what the new message is. And yeah, you might think like, okay, well, why is this useful? We'll be able to see it later in the dashboard. So that's it. That's our very simple, straightforward hello world smart contract. This contract takes in an initial argument. It stores that string, and then anybody can come along and call this update function and update what that message is. So let's save that. And now we're going to hook it up to our Alchemy application that we created earlier. We're going to connect it with our Metamask wallet that we also set up with some fake ether so that we can actually deploy and be the owner of this smart contract. So let us do this. And the way we're going to do it is inside this hard hat config, we're going to need to set some stuff up, like what's the API key of Alchemy, and what is the wallet password that we want to use to deploy to make sure that the hard hat system knows it's us deploying it and not some random person. So in order for us to manage all of that, we're going to use this tool called .env. And so we can install that with npm install .env -- save. So that will save it into our project, save the .env module. And then the key thing to know with this .env module is that you need a .env file to really use it. So we're going to hit new file, type in .env. And having this file is super great, and using it with .env because I can put in all my secrets, you know, secret 1 equals blah, secret 2 equals blah, and you get the idea. And if I keep all my secrets in this file and then load those secrets into my actual code that I'm committing to my GitHub and whatnot, then that way it's really hard for people to actually find out what my secrets are. And the key thing you want to do with your projects, if you're actually like storing this in source control, is you want to create like a git ignore and then put the .env file in there. So you want to make sure you ignore this environment file so that it's not actually shown to the rest of the internet. And then in all of your other files that you do share with everybody, you load your env. Okay, cool. So anyways, we installed .env, we started a .env file, and we don't actually want these variables, but what we will have in here is going to be the Alchemy API URL and the private key of your MetaMask private key. So remember earlier when I said that on here, on your dashboard, we're going to be using the API key. So let's click back into this app here, apps. You can find your Hello World app, or you can go to dashboard and find your app. And then you're gonna hit view key. So over here, view key, and just copy this first string right here and put that in. So pretty straightforward. That's your API URL key. And then for MetaMask, I'm gonna show you on my fake new account here that I don't care too much if you hack it. Well, actually, no, I'm not gonna show you. It's not good hygiene. But anyways, I'll show you the steps to get it. You go to account details. And what we want to get is the private key. So you hit export private key, and then you're going to type in your password. So I'll just type it in and blur out everything so that you can't see it. MetaMask password. And then boom, it says, warning, never disclose this key. Anyone with your private keys can steal any assets held in your account. So really make sure that nobody sees this ever. But I'm going to copy that over into my .m file, okay? And then once you have this set, you don't have to touch this file anymore. Now we can do something really cool inside the hard hat configuration. We're gonna go here, and I'm just gonna copy and paste this in right here and talk through it. So this is our new hard hat config. The first line right here is to require the .env and then call the config. So this basically loads all the information in your .env file into your development environment, because this is like the first file that hard hat will load. So it's going to be applied across your entire application, which is great. And then the next thing is we're going to use this plugin called ethers.js, and that's going to help us write our deploy script. And also if you want to do front end stuff later on, same library is going to be really useful. So we actually do need to install this. So let's go down here and do npm install. Let me clear this so it's easier for you to see. So npm install save dev at nomic labs hard hat ethers at version 5.0.0. So we'll let that install, but that's what this line is. It's making sure that that dependency is loaded. And then you can see the magic of the .env happening right here. This is the API URL that we defined in the .env and the private key that we defined in the .env being loaded into variables that we can use inside of our code here without actually exposing what the hard-coded values are, which is awesome. So you see we still have Solidity version 7.7.3. We have our default network is Ropsten. This is kind of optional. You don't have to include this line if you don't want to. It's just like for convenience. And then you see here in the network section, when we open that up, there's the hard hat network. We're not going to change any configurations there, but what we are using the API URL and the private key for is the Robston testnet. So this URL configuration is telling us that we want to deploy to our app here on the Alchemy application, the Alchemy dashboard. And the account that we're going to use to deploy is that private key of the account that we set up on Metamask. So this kind of says like, this is who I am in the Ethereum universe. And this is how I'm going to talk to the Ethereum blockchain. This is like that endpoint I'm going to hit. So that's what that is. And now that we have the configurations, we can actually start writing the deploy script. So I'm going to clear this real quick. And one thing we're going to do before we write the deploy script is we're going to compile. So npx hard hat compile. And this basically is a sanity check to make sure that the Solidity code that we're writing here is legal. We're not doing anything super crazy that the compiler is unhappy about. And it's not. It compiled the file with version 0.7.3 Solidity, and it finished successfully, which is awesome. So now that we did that, now we can write the deploy script. So let's go to scripts. Create a new file. We're going to call it deploy.js. Surprise, surprise. And inside the deploy script, we're going to have this async function called main. It's just the main function of the file. And then down here, we're actually going to call the main function. So there's main, and then we got to do some of this like good housekeeping stuff. I actually don't know what these couple of lines do, but it's just good hygiene, I think. In case there's an error, you just make sure you exit out of the program, something like that. But the key thing to focus on here is inside the async main function. what we're going to do is we're going to first load our smart contract that we compiled. And it's going to look like this. Const hello world equals to await ethers.getContractFactory hello world. This ethers comes from this hard hat config where we required the ethers plugin from hard hat that we installed. So we have that reference, and then we can call this getContractFactory function on hello world. Hello world, this like loaded code is actually going to be inside of artifacts, contracts, slash hello world.sol, hello world.json. And because it's called hello world, hard hat knows how to look for that, this ABI, this application binary interface, to get that contract factory. And this contract factory, this hello world that we are now defining and instantiating, is a factory for creating instances of the hello world contract that we can interact with. So in the next line, we're actually going to create that instance. So let's just call it hello world. This is going to be the actual instance of the contract. And the way we get the instance is we await for a call to the contract factory dot deploy. So hello world dot deploy. And then remember how in the constructor, we said that this is required. We require an init message to be supplied in order to deploy it. So this init message is gonna be what this is in here, and we can call this hello world. That's our initial message. So we've now deployed an instance of that contract. We have to wait for that deployment to finish. So that's why we have this await here. And after we finish waiting, then we can just do a sanity check where we console.log out the that the contract was deployed to address hello world.address. And this should print out the address of that contract. So that's pretty much it. That's the deploy script. We have the Solidity smart contract written out, and now we're pretty much ready to deploy. So this is the moment you've been waiting for. Let's clear this again. And the command is npx hardhat run. And then we're going to go into the scripts folder and load the deploy script. And then you're going to make sure you specify the network is Ropsten. If you don't specify this network, it's just going to use whatever the default is. And so you'll notice here that we actually did set the default to be Ropsten. So whether or not you use this flag right now in our example, you'll probably hit Ropsten, which is good. But if you were to leave this out, then the default would actually be hard hat, which is your local device, like local computer, and then it won't work correctly. So just make sure you have this flag, and then now you know what that flag is for. So if I hit that, it's going to deploy, and it might take a moment, but then we will be able to see that it was deployed to an address. And so far, right now, it is undefined, which is interesting. So let's debug this real quick. What did I do wrong here? Oh, I'm derping over here. So this has 3 Ds in it. It should just be 1 D. So I'm actually going to redeploy this. I checked Etherscan real quick, and you can see 53 seconds ago I did deploy a contract, but I'm actually just going to redeploy it because I need the address to show up. And one thing you can do is you can go into a blockchain explorer like Etherscan, and you can click on the transaction hash, and then you can get the address where it was deployed. So you can see here that this is my address, my wallet address on Metamask. It matches 0x7e67. This is 0x7e67. And I initiated the transaction from my wallet, and then I deploy the contract to this address, so 0x71bc. So I could just use this, but for your purposes, you should just make sure that this D is correct. And then when you run the deploy, what I'm doing here is it's going to redeploy. It's not going to replace the original one. It's actually going to create a new contract on the blockchain, which you'll see in a second. But now you can see that this contract was deployed to address 0x68df. So you do want to keep track of this address. So I'm actually just going to paste it on the side here. But if I go back to Etherscan and refresh my wallet, you can see here, this was the first one that I deployed. with the mistaken console.log. And then this is the second one to the new address 0x68df. So that matches this one right here, 0x68df. Okay, cool. So now we have it deployed, which is super awesome. And that's not the end of it though, because we just finished deploying, right? So it's like, okay, now what do we do with it? So what we want to do now, before we actually interact with the smart contract, you can go back to your Alchemy dashboard, and you'll notice how everything still says 0 right now. But if we refresh, there's actually going to be a bunch of requests in here because we started using Alchemy to talk to the Ethereum Ropsten test network. So we've made 28 total requests, and this is how many compute units we have. This is the medium speed, which is pretty fast. And then you can see here, like part of what we do is we make sure that we're talking to the right blockchain. So we talk to chain ID 3, which is the Robston test network blockchain. And then we're estimating some gas for how much gas we'll need to spend to deploy the contract. We get the block number where the transaction is happening, and then we actually send the contract code. So you can look into the raw request here and see that this is actually a compiled version of our contract. And then our response is the address where it's deployed. So yeah, a lot of really cool information that you might get into once you're actually doing some like serious development. But for now, all this information is there. All right, so that is the end of part 1. And by the end of this part, you have finished deploying and building your smart contract, your very first smart contract. So congratulations. If you want to learn how to interact with the smart contract and then verify your smart contract on Etherscan, then make sure you click through to the following parts. It's gonna show up somewhere over here. So yeah, keep watching.